think before we get started, a little bit of background on how this came about. Mike and I met in the early days of Memfault. I had recently left Oculus and decided to dedicate my time to building better tools and helping companies build better products and fix problems that they run into. And it was a pretty great encounter. I got to learn a lot about the Diamond Kinetics team, which we'll talk about in a bit. And I think most interestingly, we decided pretty quickly to see if we could work together to help make Diamond Kinetics products the best it can possibly be. And so in the process, Diamond Kinetics and Memfault, obviously they're a customer of ours, but this has been a collaborative relationship from the beginning. And so what we're excited to talk about today is what did we find when we started measuring data from the performance of a fleet of devices out there in the world, and what kind of techniques and what were we able to achieve trying to fix some of the bugs that the Diamond Kinetics was running into by kind of building observability and building some remote capability, debugging capability together. And so I'm very excited to do this presentation with Mike, who's been a veteran of the sport tech industry his entire career. And I think the best place to start, I'll turn it over to Mike, and we'll talk a little bit about Diamond Kinetics, the kind of products they make, and how they're connected to the internet. So out to you, Mike.
Awesome, thanks, Francois. So yeah, I'll give a little bit of background on Diamond Kinetics and what we are and what we do. So I'm sitting in front of a wall full of bats. We are a baseball company. So we manufacture devices. So I have one here. So one little sensor here, as you can see in the image down below, it is something that goes into or onto a bat. And these little sensors have IMUs in them, MEM sensors, and they record the motions of the bat, and we're able to generate some pretty amazing 3D and metrics to be used for coaches and players to track their swings and get better and have fun while they're doing it. After starting on the bat, we then had to go to the ball because that's pretty cool too, and is another amazing motion inside of the sport of baseball and softball. So it ends up being the same sort of hardware platform that we have that goes, this is just the same hardware platform, but pulled out of the plastics, and then we have embedded the same chip right here in the ball, right in the center of the ball. So you wouldn't know it by looking at it, but the balls that we manufacture are smart. They feel just like normal balls, and it is kind of magic every single time I see that work. And you're able to throw a ball or swing a bat and then see the full 3D pop up out of it. So I met Francois when we were starting our journey into Gen 3. So our Gen 2 devices were CSR 8670. It's sort of a custom audio system on a chip with an assembly language that you'd write in. So it wasn't super user friendly for everything we wanted to do, but we made it work. And we were very excited to get started on Gen 3, which is now built on Dialog, running FreeRTOS, and we're programming in C, so a lot easier for development. But one of the things that we struggled with was around observability. So I was very pleased to get started with Memfault. So the way that we work, all of these devices are connected to our mobile app. It's all via Bluetooth, and then the mobile app transmits all of our data up to our cloud. Any one of those connections could go down at any moment. Sort of the nature of baseball is the balls can get thrown pretty far away from the app itself and the physical phone, so those connections drop fairly often. And then our network connection is never guaranteed. Our users end up often being inside of warehouses or other places that don't really get good cell reception. So that ends up being our setup and sort of the environment that we operate in. And in Gen 2, when we put our devices out there, we had a hard time with figuring out what was going wrong with our customers' firmware, right? So it's something that I call psychic debugging. It's when you don't really know exactly what's going wrong, but the customer is giving you sort of the what happened here? I was taking some swings and I was walking away, but we never had any stack traces. We never had anything that would really pin it down. And we really had to sort of pin our hopes on, are we going to be able to reproduce this locally? Are we going to be able to think through what could have possibly been happening, intuit that it must happen in this particular section of code, and then arrive at, oh, okay, we shifted a bit incorrectly here, and et cetera, et cetera. So that's all of the psychic debugging, right? There were lots of hours spent debugging there that we probably could have saved. You know, one of the things that we were looking to get here with Memfault is some of the lack of crash logs and stack traces really ended up being a real big problem for us. That extended into extra long QA cycles. We wanted to make sure that we were putting our Gen 2 product out there in the market, and our users were not going to see lots of crashes and a lot of reboots. So the risk of launching any change to our firmware was rather high. We had to update our entire fleet at once. We had to make sure that we weren't going to cause additional crashes or issues. And you know, we might put something out there, and in fact, this has happened. We put things out there, and we had a regression on a particular issue with our Gen 2. We didn't know it. We started losing customers and dollars, right? And so we ended up spending a lot more dev testing and QA testing, and it became a very labor-intensive project for us. So it took some time for us to get to a particular release, and our cycles were very, very long. And I thought that this was just the way of embedded development. But studies have shown that developers on average spend about 40% of their development cycle debugging. Right? This was from an embedded, we got defining right debugging mindset, false errors, and bugs. This is all from an embedded industry, EE Times embedded 2019 marketing study. But it doesn't have to be that way. It's sort of what I was trying to get to, and trying to figure out what we could do about this problem of observability, and that's when I met François. So we integrated with Memfault from day one. We built them into our custom FreeRTOS image. We had a dev complete working firmware inside of 2 weeks on our custom FreeRTOS implementation. We were able to accelerate development in a number of different areas just using the SDK provided by Memfault. We were able to get some prototype data dumps coming off much faster than we thought we'd be able to. And really what ended up happening all throughout this development cycle is that we were able to put a new firmware image out there for our own internal development testing, and then really understand very quickly what was happening on those devices. We saw a lot more reboots than we were expecting. But we were able to gain confidence in our ability to observe the error, fix the error, because we knew we had the stack traces for it, and then put that out there. So our dev cycle got much shorter. And the framework that Memfault has put in place solved one of the most pernicious issues that we've come across as an IoT company, is keeping our devices in sort of a lockstep with our apps. That can get somewhat tricky for us. We had a number of custom solutions for it, and Memfault was able to work with us in putting something out on top of what they had already built for their customers around cohorts, which is pretty neat. So to talk a little bit more about Memfault, I'll let François take it from here.
Thanks, Mike. And so I think the first thing that we started talking about when Mike and I decided to work together was, you know, how were we going to collect the diagnostics data we needed, and how were we going to get it to the cloud so that we can process it? And of course, you know, Diamond Kinetics already had a data path. They already had a way to get data kind of off the baseballs and the bats and into the cloud. And so, you know, the diagnostics payload that we decided to collect from their devices in order to understand, are devices crashing? Is the battery life what we expect? You know, is the connectivity working reliably? Basically are transiting over the exact same transport. There's really no other option. So we built a custom SDK that we integrated into the Diamond Kinetics firmware. as Mike said, it took a couple of weeks, and it integrates into fault handlers, it integrates into the RTOS, and collects kind of all kinds of interesting data and debug information. When the device isn't connected, if it's being kind of actively thrown or is out there somewhere in the world with no internet, both the baseball and the smartphone will store the data locally to be uploaded later after the fact. And eventually all of that data makes it to the Memfault cloud, where we analyze this diagnostics information. And I'm going to tell you in a few slides, what did we learn, right? Like, what kind of crashes did we run into? What kind of statistics became really interesting? But first, a quick note on what happens once that data gets into the cloud. This is a very busy slide, and I'll just touch upon a couple of things. But long story short, from the Diamond Kinetics device, we decided to collect 6 pieces of data: logs from their application and errors from the application. So that's basically error triggered in our SDK, something that the app codes in their firmware decides isn't going right, as well as logs from the operating system, FreeRTOS, and errors from FreeRTOS. So we hook into the Stack Overflow detection hook in FreeRTOS. We hook into deadlock detection, mutex APIs, things like that. And we decided to collect debug registers, something like the fault registers on an ARM microcontroller, as well as regions of memory. So we take all of this data, we send it over Bluetooth to the mobile app, we send it to the cloud, and then our cloud services basically crunch all that data. They analyze the memory regions, they desymbolicate data so that we can map variables back to memory addresses, they deduplicate problems so that if the same issue happens on 1,000 different devices, we can identify it as such. And then we have a bunch of UI that our users consume, and the Diamond Kinetics team has been using to understand what's the state of my fleet, where should I spend my time to improve it. So what did we find out? Well, first, this isn't unique to the Diamond Kinetics team. It turns out every single team that we've worked with found out that their device reboots a lot. I think firmware engineer will often tell you that their firmware is very simple, very stable. And what we find is that actually these devices have all kinds of problems. And of course, rebooting isn't just always a bad thing. Sometimes you're rebooting because you're updating the firmware of the device, or you're rebooting because the user turned the device on and then back off and then back on. But we also found that every day there was a non-trivial number of faults being triggered, assertions being triggered, devices unexpectedly losing power. And so I think, it was a little bit jarring for Mike, I'm sure, at the beginning when we told him, hey, by the way, like, you have hundreds, sometimes even thousands of reboots in one day. And this is something that we can actually start focusing on. So I think the first step was measuring it and finding out, wow, these devices reboot a lot more than we thought. And so we thought, okay, so now that we know that devices have quite a few issues, like every fleet that we've ever worked on, let's find the top few issues and let's see what data we can give the Diamond Kinetics team so that they can fix it. So what did those few issues look like? So here I picked 3 issues from the Diamond Kinetics project, and we see, there's all kinds of issues. For example, we found that sometimes when users plugged in their charger into, the Diamond Kinetics device, the device would crash. So it didn't happen a ton. I think it happened a few hundred times, but that was interesting, especially since no user had actually reported that. We found that sometimes there's a couple different code paths when there was a lot of data being processed at once, or because of a little timing issue, a lot of data would get processed at the same time. Sometimes the device would run out of memory and have a Stack Overflow condition. And of course, I think the number one issue, the thing that ended up driving actually a lot of the resets with Diamond Kinetics, it turned out was not Diamond Kinetics' fault at all. It was a bug in their in the BLE controller, which was provided by their silicon vendor, Dialog. You can see, like, to date, there's been maybe 34,000 times that specific crash has been triggered and detected by Memfault software and uploaded to the cloud. And we were able to identify that within kind of days of starting to work together. But of course, you know, we couldn't quite solve that ourselves because we needed some help from Dialog, and I'll get to that in a second. The data that we did collect, though, I think pretty, you know, already helped us, you know, get very tangible information. So you can see here that we can see the backtrace for the active interrupt. So we can see that, you know, for this specific Bluetooth controller crash, we can look at the actual code path. We were in, you know, we first called PM get sys wake up cycles, then we went into the CMAC error handler, and then this function called BLE controller error. We have all the registers and local variables. We have what all the other tasks on the system are doing. So we actually had a lot of data. And so we had everything we needed to work with the Dialog team and the Diamond Kinetics team to get to the bottom of this issue that was happening on you know, thousands and thousands of their devices and driving a meaningful amount of their connectivity issue, a meaningful amount of their reboots. Did we fix it? Yes, we did. I'm very excited about that. We were able to basically send all this data that Memfault collected to the Dialog team, and collaboration between Dialog, Memfault, and Diamond Kinetics led us to a fix. And so, you know, I think, and beyond fixing this together and working together with hard data, which was very exciting because it saved engineers a month of work. We also were able to quantify the issue. And so one of the interesting things is that Mike actually made the decision to go to market, to release their device, even though they had run into this issue. And the reason they did that is that thanks to our collaboration, they had a good understanding of how often this happens, how quickly does the device become available again, and what's the actual impact of this problem. And so given that we had all the data we needed to fix it, it was in progress, and we understood the impact, I think Mike was able to make kind of a data-driven decision and ship his device on time, knowing that a fix would come and that we had all the data we needed. So I was very proud of this one. I think this was a really powerful result of our collaboration. Fixing a chip bug together in the fields, I thought was a great journey. And I think at a higher level, we also, you know, took a look after a few months of working together, like how are the devices doing? And I'm very proud to say that by working together, we managed to reduce the number of resets per device in the Diamond Kinetics fleet by over 90%. So at the beginning of our engagement together, as I said, the devices resetted quite a bit. And in fact, we found that on average, each device in the Diamond Kinetics fleet would reset 4.5 times per month. That means about once a week or a little more than once a week, device would reset. By the end of our engagement, so today, and we're still actually working together, so this is going to continue improving, but today, that same fleet of devices, on average, each device will reset about 0.4 times per month. So actually, most devices will only reset once every 2 months. A major improvement, and you can imagine that means a 90% reduction in. This is just a proxy for all kinds of issues. Means a 90% reduction, probably, you know, to some extent in problem like software-related customer service calls. It means a 90% reduction in people having having issues pairing their device with a Bluetooth because it crashes during the pairing or something like that. This is actually meaningful both for the end user experience of the device and for the operations of the company. But I think more than the hard number, and I'm going to turn it over to Mike to talk about this, what I found most exciting is to see kind of the qualitative impact it had and how it helped them change the way they do product development. And Mike, I'm going to turn it over to you to talk about that a little bit.
Yeah, and I hope you guys can see it, right? It sort of jumps off the page to me, like 90% reduction is phenomenal. And the information that you're seeing, those are the real stack traces from our devices. We have so much more confidence in our ability to release. Like you heard François say, you know, that I chose to launch this product knowing that we had this pernicious issue out there that was causing these resets. we were able to work around it, but we knew that we would get all of that information back. We would have those real-time alerts. We'd have full visibility into any of the issues, and we'd be able to resolve them quickly, right? It wasn't just our developers and their confidence, right? This was a full team. Our interaction with our customer support has changed dramatically for the positive, right? You know, you get the call from customer support and it's like, oh, what broke? What happened? Now we know. In many cases, we can see these logs before customer support sees them because they're coming off in real time. And you know, if our customer support reaches out to our tier 3 or tier 4 support, we can look at the logs for that particular customer. It's phenomenal. And you know, we're given that we have the confidence, and you know, this is more like web development, is more like back-end development. I have all these stack traces. I am able to get into a release train and a release cycle that is much more reminiscent of the web app development than it has ever been for me inside of embedded development. And that's fantastic. I can control my launches, I can control my rollouts, and I get all of the telemetry coming back from my entire fleet, which is phenomenal. And so we've got a little quote to go with it as a baseball company. It is a Babe Ruth quote that I butcher here on the next slide, but you know, never let the fear of striking out keep you from playing the game, I think is a really good quote from Babe Ruth. And I changed up just a little here to say, you know, never let the fear of bugs keep you from shipping your products, said Babe Ruth, said Mike Ressler. But, you know, that's an easy thing to say on the web dev world and on the Java world. I was petrified of shipping products and taking out my entire fleet with my Gen 2 devices, and I'm not with my Gen 3, and I hope everyone has that experience. Getting observability is, I would not ship products without the observability that we have today. And that's all. That is what I got for you guys today.
Awesome. Thanks, Mike. And so, you know, in summary, I think we're happy to answer questions and talk more about this. But long story short, you know, Diamond Kinetics has been a great partner and an early customer for us at Memfault. We really were able to dig deep and find things like silicon bugs and really improve the stability and I would say uptime of their devices, which has been very rewarding. We've also gotten, you know, to know the Diamond Kinetics team very well and really learn kind of what are the things that are important to them. So it's been very exciting. I'm proud to be able to present all this to you with Mike today. And I look forward to your questions. If you want to get in touch after this presentation or after you watch the recording of it, you can find us by email, you can reach us on LinkedIn, and of course on Twitter, where we're both, I would say, maybe a little bit too much. I look forward to engaging with all of you, and happy to answer any questions you may have.